Hey, what's up, everybody? This is page 373. We are going to be talking about the tangent to a circle theorem. And I encourage you to find this card, the Inscribed Angles Theorem, right? In that card, we're talking about how the measure of the inscribed angle is half of the measure of its intercepted arc. And the arc that we're going to be creating is using the tangent, the line that barely touches the corner of a circle. So to be ready for today, have a highlighter, have something that you can use to write with, and let's also be reminded what learning goal that this actually came from. So all the way back on page 355, when we started this unit, right, here's my screen. We're going to come back to our work here in a second. We are going to construct a tangent line to a circle from a point outside the circle, and then we're going to use the tangent to a circle theorem. So we did the construct a tangent line when we were on the previous lessons, right? We did that, I think, on page 368 or 369. Specifically 367. But we're using the fact that when you create a tangent line to a circle, it creates some nice angles, some angles that we can actually, continue to talk about. Highlight the habits of mind. As mathematicians and mathematics learners, we are trying to become better at reasoning abstractly and quantitatively. We are trying to become better at constructing viable arguments and critiquing the reasoning of others. Think back to the previous case of exterior angles that you drew involving a secant and a tangent. So specifically the exterior angles of a circle theorem. Right? In that activity, there was a special case where the secant contains the diameter of a circle. So I'm going to highlight secant green, and I'm going to highlight this is what they're talking about. Okay? That secant line, it's a chord in this case because it stops. It goes through the middle, through the diameter of the circle. Question 1. Consider angle UTV with a vertex located on circle C. And if you remember, an inscribed angle, it's one of our vocab words, inscribed. It's the angle that's created where the vertex is not on the center. It's on the edge of the circle. And we have the inscribed angle theorem, which says an angle whose measure is half the measure of its intercepted arc. So that's our remember. Consider angle UTV with vertex located on circle C. Then let's draw a line VW tangent to the circle at this point T. So a little highlight orange. We're going to draw a line VW tangent to the circle at point T. And the color just makes things kind of like stand out, kind of pop. The more you see it and you interact with it, well, the better you'll remember it, the better it'll like land in your memory. Let's determine the measure of the arc UXT. So they have to give us 3 letters because we have to know, are we moving to the right side or to the left side? Which section of the circle? So if we're moving on the left side, UXT, that would be over here. And then on the right side would be arc UYT. Right, that's the goal. The goal is to make sure that we're talking about those arcs specifically, and I've exhausted all 4 colors of my highlighters for right now, okay? So here's one thing that we know, right? If UT is a diameter, then the arc that's created on that diameter has to be half of a circle. So therefore, the measure of UXT is 180. But you know what? The diameter cut the circle in half, so that's also the same thing for the measure of UYT. The measure of UYT is also 180. Really, because UT is the diameter. So it creates half of a circle. It cuts the edge of the circle into 2 equal sections. Right? UT is the diameter of circle C. Okay? Well, then, if that's the case, right, remember the inscribed angle theorem. That this arc right here, UXT, as a 180 degrees, it will tell us the measure of an inscribed angle that is created with it. That's what part B is saying. Determine the measure of angle UTV. So in our diagram, UTV goes along the green and then out here to the left. So this angle is the angle UTV that we're talking about. And because of the inscribed angle theorem, it has to be half of the measure of this arc. So I'm gonna show some notes, and then I'm gonna produce a number. 1/2 of the measure of arc UXT, which means 1/2 of 180, which therefore means 90 degrees. That's UTV. The same thing is true for UTW. The angle over here, right, this angle created with the secant that goes through the diameter. So it's creating a 180 degree intercepted arc, and then the angle that's created is half of that arc. So full-on notation would look like this. The measure of angle UTW equals 1/2 the measure of arc UYT, which is 1/2 of 180, which is 90 degrees. It appears that when a line is drawn tangent to a circle, the angles formed at that point of tangency are right angles, and therefore the radius drawn to the point of tangency is perpendicular. Good old word for us to use. Perpendicular down here. Perpendicular means that the angles cross at right angles, and it's also symbolized with an upside down T shape. See, check that down over there, okay? You can prove this relationship and then state it as a theorem. And that's what we're going to do. We're going to explore it. We're going to more than we already have, and then we're going to write a proof for it. So thank you for watching this setup video for page 373. We got to continue on eventually to the point where we can create its own card, but for the tangent to a circle. So click on page 374's video, and let's keep rolling.